So today is all about factoring. We're going to do 3 types of factoring today, and then on Monday, after you take your quiz, we're going to do a couple other types of factoring. So the first type that we are going to do is GCF, our greatest common factor. So go ahead and write that on your paper. GCF, greatest common factor. What does greatest common factor mean? That's right. It is the greatest number that goes into all the terms that you have. And a lot of times we just have 2 terms, but sometimes we have 3. So it's the biggest number that goes into all of that. So over here we have 4 polynomials, and we are going to find the GCF of all 4 of these. Okay, so think about what is the biggest thing that goes into every term. So in our first problem, we have 8x minus 4. Now, do both terms have a variable? No, so it can't be a variable. So we just look at the whole numbers, 8 and 4. What's the biggest number that goes into 8 and 4? 4. That's our GCF. All right, let's look at the second problem. We have 15x and 45x squared. Let's start with the whole numbers. What's the biggest number that goes into 15 and 45? 15. Good. Now, do both terms have a variable? Yes. When they both have a variable, you think about how many that they share or how many they have in common. Okay? Also, a hint for this is pick the lowest amount that they have. So we have an x and we have an x squared, which is x times x. So would it be an x or would it be x squared that they have in common? Just x. Good. So our final answer for GCF would be 15x. Problem 3 says 6x squared plus 12x minus 21. Let's start with the numbers. Now, when you have a trinomial with 3 terms, you have to look at all 3 terms to figure out the GCF. So what goes into 6, 12, and 21? 3. 3 is the greatest common factor. Can I say 3x here? Very good. We cannot say x because 21 does not have a variable with it, so we can't say x. It's just 3. What's our greatest common factor between 11x minus 7? 1. Very good. Some people try to say 0 here, but remember 1 is a number and that will go into both terms. So this one is just 1. Have y'all done GCF before? Sound familiar? Did you know your calculator can help you find the GCF of just 2 numbers? All right, everybody grab out your graphing calculators if you don't have them out. I'm going to show you a lot of tips and tricks on your calculator. So Ms. Hopkins may have shown you this one as well. For this one? This one? This one? So 4 will go into 4 and 8, right? So 4 goes into 4 one time and 4 goes into 8 twice. So you look for just the biggest number that will go into both. So 4. The x doesn't matter because this doesn't have an x with it. You just want to know what will go into the whole numbers evenly. So when you find the GCF as a number, don't worry about the variables. Just look at the numbers. And when we do our next few problems, you might see how it relates a little bit easier. All right, let's go to those calculators real quick to make sure you guys know how to find your GCF on your calculator. This is a great tip or trick to use. Now, your calculator will only find the GCF between 2 positive numbers. So you can only type in 2 positive numbers. So first hit math. And then you're going to, right arrow to number, and then scroll down to option 9. Now, option 9 says GCD. What do you think D stands for, though? Denominator. Yep. GCF and GCD are pretty much the same thing. Greatest common denominator, greatest common factor. So we hit math, right arrow, and option 9. You might want to write these steps down maybe on your paper just so that way you have them for later. So math, right arrow, option 9, GCD. And then you type in two numbers like 6, and then you put a comma between, so the comma's above the 7. And then you can type in maybe 21. So what's the GCF between 6 and 21? 3. And then if you wanted to look between some other numbers, you could do like your 8 and 4. Oops, didn't mean to click mode. Well, I hit the wrong button. So math, right arrow, option 9, 8, 4. So GCF is 4. So again, only can be used between two positive numbers. Okay. Let's go back in here and try some more problems. We're going to do some factoring now. So write down those instructions, and then you can write down each of those problems. I would save at least 2 lines between each one, or if you want to write them down one at a time and we will do them together, then that is fine. Our goal here is to factor all kinds of different polynomials that we have. And the first thing we always look for on every single problem is that GCF. You want to start with that. Now, your GCF, greatest common factor. So let's see, what's the GCF with 14D minus 2? 2. So what you do with your GCF is you divide that number by each term, just like we did at the end of yesterday's lesson, just like you had it on your worksheet last night. You divide it out. You also put that number in the front and then put parentheses. So that's really the only difference from the division. Now, what's 14D divided by 2? 7D. What's 2 divided by 2? 1. So we get 2, and then in parentheses, 7D minus 1. If you were to distribute that 2 back, would you get the exact same problem? Yes, you would. That's a way to double check yourself. So double check by distributing back, do you get the same thing? Another thing you should double check is your parentheses. 7D minus 1. What's the GCF with 7D minus 1? 1. As long as your parenthesis has a GCF of 1, then you did it correctly. So if you factor out the wrong number, your GCF will not be 1 in that parentheses. All right, write down problem 5. X to the third minus 5x. What would be your GCF of that one? X. They both have a variable, and the smallest variable is x. So we divide both terms by x, put the x on the front, and divide it out. Now, what do you do if there is a power over a power? Subtract. So what do I get inside my parenthesis? And what comes next? Minus 5. Very good. So if you distributed that x back, would you get the original problem? Inside the parentheses, does it have a GCF of 1? Yes, those are your 2 things that you check. Check, check. Very good. All right, write down problem number 6. 4a to the third minus 20a squared minus 8a. Now, start with your whole numbers first. We got 4, 20, and 8. What's the GCF? 4. Is there also a variable? Yep, you could say 4a. So I'm going to divide every term by 4a. And then I put that in front of my parentheses. And I divide it out. So what's my first term in my parentheses? Good. A squared. That's right, because a power over a power, we subtract the a's down there at the end, cancel out. If you distribute it back, would you get the same thing? Inside that parenthesis, does it have a GCF of 1? Okay, then we did it right. All right, let's look at our last one. Negative 5x squared minus 15. What do you think that GCF might be? A 5? Negative 5? I would go with negative 5. Typically, this is what we say with GCF, and you'll see this more on Monday. If the first term is negative, you factor out a negative. So since that starts out as a negative here, we're going to factor out a negative 5. Do I need to factor out negative 5x or just negative 5? Just negative 5. Okay. So I put my negative 5, and then I put parentheses. Good. X squared plus 3. If I distributed back, would I get the original? Is the GCF inside the parenthesis 1? Then we're good to go. All right, you guys, try these 3. Technically, it is not, because if they share that negative, you want to take that out because that is something that they have in common. So you do want to take out the negative. Logan, you just look so depressed about that. You're like, oh. Should I spin the wheel? Still have third period names up here. All right, let's spin the wheel. Our first participant is Piper. You get problem number 1. We're going to have a lot of participants today. And who gets to do number 2? Let's see, that would be Aiden. And problem number 3 goes to Melanie. All right, check with your neighbor too. If you're done, check with your neighbors. Make sure they have the same thing. Oh, hold on a second. Don't use this pen. I'm sorry, because then I can't write anymore on it. Use this one. You can still use orange if you want to. Yes, you can. Now remember, double check your answer. If you distribute it back, do you get the same thing? Does the parentheses have a GCF of 1? Does the parentheses do? It should be do, doesn't it? Do the parentheses? Does the parentheses? I don't know. I teach math, people. I teach math. I like how Melanie's our little cheerleader in here. So look for that GCF. What do they have in common? Do you like Melanie's encouragement there? Just love it. Oh, put it back on. I could just like hit you with it. Here we go. I will take your pen. All right, did you guys get the same thing? Let's just double check. I like to look at my parentheses. Do they have a GCF of 1? Looks like they all do. If I distributed back, that would be an 8x squared minus 12x, 5d to the third minus 10d, 6m to the third minus 12m squared minus 24m. Very good. Give yourselves a round of applause. Get it round. All right, how does GCF feel for you guys? You remember it a little bit from last year? Especially if you had Math 1 in the fall. This is probably going a little bit easier, right? Because I know y'all did a lot of these with Miss Hopkins. So making sure you pull out that biggest GCF, making sure the GCF inside the parenthesis is 1. All right, we're going to look at our next type. That is our first type. Tonight, you're going to have a worksheet, and it's separated just like how these problems are. So you find the GCF just like we did on the first slide, and then you factor out using the GCF like we did on this one. So now let's look at our next group of problems. But before we get there, we need to make a perfect squares list. Okay, perfect squares list. This one's going to be kind of long. So does anybody know what a perfect square is? That's right. If we think about a square, right, all sides are equal. And what a perfect squares list is kind of like the area of any square that has integer sides. Like what if you had squares all sides of 1? What would the area be? 1, because you would say 1 times 1, right? And so if it had a square of 2, the area would be 4. 2 times 2. What about 3? 9. That's your list of perfect squares. So perfect squares are 1 squared, which is 1. 2 squared, which is 4. 3 squared is 9. And we want to make this list all the way to 15. So what is 4 squared? And what is 5 squared? Good. I'm just going to make 3 columns since I'm writing a little bigger. 6 squared is? 7 squared is? 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. 13 squared. It's actually 169. And 14 squared is 196. This is how I remember it. This one's 69, 14's 96. They just flip. And 15 squared is 225. These numbers that you are writing down are ones that you need to recognize that they are perfect squares. The faster you recognize them, the easier and better off you are in all of your math classes that you will have. So make sure you know this list of perfect squares from 1 to 20, or 1 to 15, not to 25. 1 to 15. It's going to make your life a lot easier. Did you know your calculator will make this list for you? Let me show you that shortcut. So, because when you have a test or quiz, you don't get to use your calculator, you get to use your calculator. You don't get to have this list, but your calculator will make the list. So, in your calculator, everybody go to y equals. If you have anything listed in there, make sure you clear it all out. And then in the first blank, you're going to hit X, which is right here beside this alpha key. And then you hit the squared button. So X squared. Now, once you have that listed in Y1, you're going to hit second graph to go to your table. And then you're going to look at positive X values. And what are those Y values? There's your perfect squares. So you're going to y equals, you type in x squared, and then you hit second graph to go to your table, and there they are for you. So if you forget, that's how you find them, okay? And then it actually tells you what the square root of it is. So what's the square root of 64? 8. So we can just go from right to left to find the square root. Now, once you have your list of perfect squares, it's going to make the next part a lot easier. So the next thing on our list to factor is difference of squares. What does the word difference mean? Subtract. And squares are talking about perfect squares that we have. So, write down this information. That a little bit bigger for you. Also, difference of squares problems are always binomials. What does it mean to be a binomial? 2 terms, that's right. Okay, so difference of squares are binomials. They have the difference, which means that they have the minus, and then they have perfect squares. And how we factor these is like how it's written here in this parenthesis. So it starts out with something squared minus something squared. And then we factor it into a plus b and a minus b. So the squareds are gone. So we got to think about doing the square root. And then one parenthesis has a plus, one has a minus, but everything else is the same. So, looking at this first one, it is x squared minus 81. Is 81 a perfect square? Yes, it is. What times what makes 81? 9. So, how we factor these is we make 2 parentheses. What times what makes x squared? X. So, this is x is at the beginning because x times x makes x squared. 9 times 9 makes 81, so that goes at the end. We put a plus in one and a minus in the other. So your final answer is x plus 9, x minus 9. That's right. If we wanted to check, we could distribute. So you don't have to do this part, but I will do it to the side, but you don't have to write this down. If I went through and distributed this, I would distribute the x first, so I would get x squared minus 9x. Then I distribute the 9, and I get plus 9x minus 81. And what happens to those middle terms? They cancel out. So if you want the middle part to cancel out, you make the parentheses exactly the same with a plus in one and a minus in the other. And then that's how that one works out. So let's look at our next problem. What if we have x squared minus 64? What times what makes 64? 8. So this would factor to. Very good. And some people put x minus 8 first and then x plus 8 second, and that's perfectly fine. As long as one's positive and one's negative, it doesn't matter the order because multiplication is commutative. Now let's look at this one. This one is still a difference. And are these still perfect squares, 9 and 4? Yes. So we can go ahead and make our 2 parentheses. The only difference is we have to put something extra at the front. What times what is 9? 3. So this is actually a 3x that we're going to put at the front. What times what is 4? So we put a plus 2 and a minus 2. So our final answer is 3x plus 2, 3x minus 2. Let's do the same thing with the number 4. What would you say the answer to this one would be? Very good. 5 times 5 is 25. 4 times 4 is 16. So 5x plus 4, 5x minus 4. All right, it's your turn to do some or a lot. There is one tricky one on here. Don't forget while you're taking notes to also write the problem, so that way when you review this later, you have the problem and the answer. Because you may see some very similar ones, maybe even some of the same ones on homework tests and quizzes. Dun, dun, dun. Sometimes I take homework problems and just change the numbers a little bit too. Just spun our wheel, and Hayden, you're the lucky winner of number 1 up there. Let's see who besides Hayden gets to go. So number 2 would be Lena. We're just going to keep going down the table maybe. Let's see if Ariana's next. I think it's going to skip you. It is, but it's going to land on Drake. Drake, you have number 3. Alex, you are the lucky winner of number 4. And whenever y'all are ready, y'all can go up and put these on the board. Number 5 goes to Luke. You got number 5. And Amelia, you got number 6. Oh, I just realized I put Gracie and Lynn together. I put Gracie Lynn as the name. Ariana, you got number 7. And then I'm going to put Gracie Lynn as 2 people now. Which one did you? Oh, you had number 6. Yeah, that's right. Yep, go do that one. right, good work, everybody. If we look at these, they look great. The first one, x plus 6, x minus 6. The second one, a lot of people forget how to do this one. But 1 times 1 is 1. Like, they just want to stop on that one and be like, well, 1's not a perfect square, but it is. 1 times 1 is 1. And then here, p plus 7, p minus 7. That looks great. Now, this one here, I threw actually in a trick one. Is this one look like all the other ones on the board? What's different about number 4? There's a plus, yes. Now, if you didn't notice that and you wrote it as a minus, because I was looking at several of your papers and you automatically wrote a minus there, that would definitely go into this. But if it is written, so you can add another problem over here, if it is written as x squared plus 4, can we do it? No, this one's actually factored as much as possible. Oops, I cannot write anymore. Factored as much as possible. If it has a plus in there, you cannot do anything with it. So I did throw that one in as a little trick for you. So you can add that in maybe to the side and maybe change this one to a minus. Because if it's a minus, that will definitely work. But if it's a plus, it will not work. And some people say, well, couldn't you do x plus 2, x plus 2? But think about this example we did over here, x squared minus 81 here in orange. If it was plus, all of these would be plus, and then that middle term wouldn't cancel out. You're exactly right. So then that wouldn't work if it's a plus. These longer ones look great too. 3 times 3 makes 9. 2 times 2 makes 4. We got a plus in one, minus in the other. Number 6, 5x plus 8, 5x minus 8. And 7, 2w plus 7, 2w minus 7. So use that perfect squares chart that you guys wrote down or that list, and that'll help you match those things up and do them. So don't forget, it has to be a difference of squares, and it's always going to be a binomial with 2 terms. So next we're going to factor some trinomials, which means it has 3 terms. Or we might in a minute, because I opened up more programs and then my board decides it doesn't like me anymore. I really need to submit another tech ticket. There we go. Okay, write down all that info at the top. Okay, that's going to be really important. So write down all that info and those problems. You can save maybe 2 lines between each problem. You don't need a whole lot of space. Bless you, bless you. Okay, here we are going to be factoring trinomials that are in the form x squared plus bx plus c. So b and c are some random numbers. And then it says, notice the coefficient in front of x squared for all of these problems is what? 1. So when you look at these problems, it has a starting coefficient of 1x squared. Now, on Monday, after the quiz, we're going to talk about what if it's a different number besides 1. But for right now, we're going to look at just 1. So here is your steps. You find two numbers that multiply to be the last term and add to be the middle term. So I call this my little scrap work. And I was going to ask Miss Hopkins how she did it. I did before, but I forgot. So I'm pretty sure it's about the same. So you're going to take your last term, which is 7. And you're going to put equals blank times blank to the side. You want to figure out what multiplies to be 7. But at the same time, it has to add to be the middle. So in the middle, we have 8. So 8 is blank plus blank. So what you're trying to find is the same two numbers that multiply to be 7 and add to be 8. Now, the easiest thing to do is to think about things that multiply to be 7. Well, what's the only two numbers that multiply to be 7? 7 and 1. Is 7 plus 1 also 8? Yep. Those are your two factors, and those go straight into the parentheses. You're going to put x at the beginning, and those two numbers fill in for the back. Since they're positive, you're going to say plus and plus. So x plus 7, x plus 1. And that's your final answer. It doesn't matter what order you put it in. I'm going to go ahead and answer that one too. So if the person beside of you put x plus 1 and then x plus 7, that's perfectly fine. As long as the same things are in the parentheses, it doesn't matter which parenthesis goes first. Okay, let's look at the next one. So using the same idea, find two numbers that multiply to be the last. So we're going to do 20 equals blank times blank and add to be the middle, which is, that's right, 4 and 5 will work. What do we have to do with that 4 and 5, though, to make? That's right. We've got to make them both equal to -9, so it'll have to be -5 and -4. So -5 plus -4 makes -9. So my two parentheses are very good. X minus 5, X minus 4. No, if you can do it without the scrap work, you don't have to use that. No. So that's fine. All right, let's look at our next one. What multiplies to be 48 and adds to be -26? 24 and 2. What about 24 and 2, though? That's right. If you make them both negative, then they will make a -26. So my two parentheses are good. So there's only one set of numbers that will work, so just verify that they work. You can use your calculator to help you out. To check those numbers, you can type in -24 plus -2 just to make sure it equals -6. All right, doing our last one, what multiplies to be 64 and adds to be 16? 8 and 8. How are fast on these? I think y'all know your times table is better than the 10th graders do. Don't tell them that, although it's on video. Sorry, 10th graders. Okay, so here we go. These two parentheses would be, what do you notice about these two parentheses, though? They're the same. Here's what you have to do if you ever end up with parentheses the same. You need to write it once and put a squared on it. Yep, you're exactly right. If two things are, whoops, I have no idea what was happening there. If it doesn't like me. If two things are the same, you write it once and put a squared on it. Did you know your calculator can help you find these numbers too? Let me show you that trick, just in case you didn't know. You probably already know, though, because y'all were so smart. So you go to y equals. So everybody go to y equals real quick. Let's say we were trying to find things that multiplied to be 60 and added to be something else. I don't know. Whatever they multiply to be, you're going to type that number in and then hit divide by x. So 60 divided by x. And then go to your table. So second graph. All of this is factors of 60. 1 times 60 is 60. 2 times 30 is 60. 3 times 20 is 60, and so forth and so on. When you are doing these different ones, you want to use all the whole numbers. So you're not going to use 8 and 7.5, but you're going to use 10 and 6 or whatever numbers you have. So let's say you wanted to find two numbers that added up to be 17. So if you look here, 5 and 12 would be the two numbers, because 5 plus 12 is 17, and 5 times 12 is 60. So a helpful hint, take what you want it to multiply to be, divide it by x, and then go to your table. All right, let's see what's next on our list. Or not, because it's going to pause for a second. But I'll review for Math 1 so far. Y'all remember this? Who took it last semester? Hopefully it's still there. I like doing the scrap work, but you don't have to. Again, if you know your times tables and can add pretty quickly, but if not, do your little scrap work to the side. And here are some you try problems. We got 6, 1, 2, 3, 4, 5, and we got 7 people left. Only one person will be left out. Let's see who it is. I'll give y'all a chance to work some of these, and then I'll have you guys put them up on the board. If you want to, you can go ahead and write down all 6 problems, because you should know how much room to save, and then you can work those out. Problem number 1 is going to Lynn. Problem number 2 is going to Silas. Problem number 3. Olivia. Problem number 4. Logan. Problem number 5. Dixie. All right. China or Gracie, let's see. Who gets problem number 6? And that is going to be Gracie. Sorry, China, you don't get to write on the board today. Are you depressed? I know, she does. She looks like she's going to cry. She's just missing doing problems up here on the board. All right, y'all can come up whenever you want. Go ahead and put those answers up on the board. We can have 2 people right up there at the time, so next person want to come on up anytime, you can. Sometimes y'all write so shy on the board. They said we could like hit it and it wouldn't break, but I haven't tried that yet. With my board at West, one time I had this game where it was like baseball, so you were supposed to like throw a ball at it, like a soft ball, and then, not a soft ball, but a soft squishy one, and then it would find a problem and it would do the problem or whatever, or it would pop up. So you're supposed to kind of like play baseball to find the problem. And I think one of the guys threw it kind of hard at my board, and I was like, okay, we're just going to go up and touch the problem you want to do now. Because they were like, well, bam. It was kind of funny. Now, we have a what on Monday? A quiz. I emailed them yesterday, so hopefully everybody knows them today. It'll probably be the day we take the math exam, that Friday, May 16th, and we'll go from 1 to 2. Yeah, we talked about it yesterday during the meeting, but there were a lot of people who were gone yesterday. So, but I don't know if Tyler, I don't know if Tyler put it in the email or not. I doubt he did. Yeah, but it'll be in May. Yeah, probably May 16th. Now, when you are taking your quiz on Monday, if you get stuck, or even when you take the test or homework or whatever, if you get stuck and you're having a hard time finding the numbers, just call me over and I'll give you a hint on one of them. Like I might say, have you tried 2? But I won't tell you if 2 is positive or negative, and I won't tell you what the other number is. All right, let's check these out. Let's see. M plus 10, M minus 2. Well, if we multiply those, we get negative 20. If we add those, we get 8. P plus 5, P minus 8. If we add those, we get negative 3. We multiply those, we get negative 40. This one, K minus 5 squared. That's right, because they're both K minus 5. 5 times 5 is 25. Negative 5 plus negative 5 is negative 10. So don't forget to put a squared on there if the factors are the same. Then this one looks good. X minus 9, X minus 2. G plus 5, G plus 2. This one always trips people up. But 20 plus 1 makes 21, and 20 times 1 makes 20. All right. Your homework here is this worksheet. You're going to be factoring. Now remember, it's in the same order that you did your homework. So if you look at your homework, then you got these done.